So in this discussion we will talk about how to obtain demand and supply functions, and also we will somehow relate those functions to cost, revenue and profit of a business. So let's start our discussion about talking about demand and supply function first. Then we will talk about how do these two things related to cost, profit and revenue of a business. So first of all, demand and supply functions are functions that express the price of a commodity as functions of quantity demanded or supplied. In other words, demand is a function of quantity. Of course, that expresses the price. And similarly, supply is also a function of quantity, and that also expresses the price. Now, obviously, when the demand and supply meets at the market, we have equilibrium is obtained. At that time, the price is called equilibrium price, and quantity that is supplied and demanded at that point is called equilibrium quantity. In practice, these two functions are obtained through mathematical modeling, or we can also use statistical procedures to develop mathematical models. In our courses, we can either use regression analysis to simplify or a simple idea of assuming that demand or the quantity supplied and the price at which it is supplied or demanded are linearly related. In other words, demand function could be something like m of q plus some kind of a constant. Similarly, supply function is also can be expressed as supply of a quantity is same as, so let me say m1 of q plus some b1, another constant. So many of our business courses, we either simplify or simply assume that demand and supply are linear functions. However, in practice, they are not really linear functions. It could be either exponential or some other form of functions. Now, if it is a linear function, to develop a linear function only need two ordered pairs, or rather slope and a point. So let us now talk about an example here. Let's say we are talking about demand for computers. Let's say for a supplier, if they set the price of a computer to be $1,000 per computer, they were able to sell, let's say, 2,000 computers or units. Then they increase, or when they reduce the price to, let's say, $800, they were able to sell 2,500 units. Now, if we assume the relationship is linear, we are looking for a linear model. As you said, price is our y-coordinate, x-coordinate is the quantity. If that's the case, we can express these two situations as two ordered pairs. One ordered pair is 2,000 and 1,000. Other one is 2,500 and 800. Now, once we get these two ordered pairs, we can find the slope, which we normally refer as m, equals 800 minus 1,000, change in price, divided by 2,500 minus 2000, which is negative 200 over 500, or rather we can call this as negative 0.4. Now either we can use either point slope form or the model that we talked about before, P equals M of Q plus B, and we already know the slope, which is negative 0.4, so P becomes negative 0.4 Q plus B. To find out B, we could use either one of those ordered pairs. If I decided to use the first ordered pair, which is 2000 and 1000, so the price will become 1000. At the same time, the quantity will be 2000. So if I plug those two numbers in the place of P and Q, I will have 1000 equals negative 0.4 times 200. 2000 plus B. So the B will become, this is 800, so 1800. So the expected demand function of the price equals negative 0.4 Q plus 1800. Now before we leave this expression, let's try to understand these two terms here. These two numbers here. One of them is the slope. This tells you if we increase the quantity by 1 unit, the price will be reduced by 40 cents. So that is the interpretation of the slope. And 1800 is the price. So if they set the price to, if the quantity is 0, in other words, they cannot sell anything at the price at $1,800. Just a quick note here. If we are looking for a quadratic expression for the demand or the price, we will be looking for something look like this: AQ squared plus BQ plus C. To obtain this, we need at least 3 ordered pairs. If we have 3 ordered pairs, we should be able to solve for A, B, and C and obtain the quadratic demand function. So similar method can be also used to find supply functions. Again, supply S of Q is expressing price as a function of Q. As I said, if we are looking for a linear function, we will need 2 ordered pairs, or if we need quadratic function, then at least we need 3 ordered pairs, and so on. So I just for mentioning here, so it will, if it is a linear model, it might look like M1 of Q plus B1. Again, I don't need to go through the elaboration of this function because it is similar manner. The way that we did supply demand function, we can also obtain supply function. Now, in a market setup, the quantity demanded by the market or supplied by the market will be the same. In other words, supply function and the demand function will equal to each other. That situation is called equilibrium situation. Now let us turn our attention to cost, revenue, and profit of a business based on, of course, supply and demand. So let's talk about cost, revenue, and profit. Now the cost function has 2 components. One is called the fixed cost, other one is called the variable cost. Now, for any business at a particular level of production or selling, there are some costs that are fixed at the level of activity, and there are some costs, they are variable. If you do not operate, if you do not sell, or if you do not produce anything, you don't need to incur the variable cost. And it is usually expressed for every per unit. In other words, if you want to know exactly how much is the variable cost of producing certain amount of certain quantities, so what we do is we try to find out variable cost per unit, and we multiply that by how many units, or multiply by the quantity. So the cost function in essence can be expressed as fixed cost such as rent, salary, and so on, and the variable cost directly associated with the number of units. So now let us extend our previous example where the price of the quantity is given by negative 0.4 Q plus 1800, as we have derived from previous example. Now let's assume this business has a fixed cost of $20,000 and variable cost per unit, meaning per computer, let's say is about $400. So this cost is directly associated with the product itself, such as material or labor directly attributed to each one of those units. So the cost function, as we said before, has a fixed cost which is 20,000 plus variable cost per unit which is 400 times the quantity. So this is basically the cost function. Now let's talk about the revenue function. Revenue is always price times the quantity. In other words, what is the selling price times what is how many units are being sold. In real life situation, the price, demand and supply equal to the same thing, so that the P might represent the equilibrium price. So anyway, so if I use this expression, price times quantity is revenue, so if I multiply the price, which is, we have an expression for price as we introduced before, which is negative 0.4 Q plus 1800 times the quantity Q, so which will be then the revenue R will be same as negative 0.4 Q squared plus 1800 Q. Now if you like to obtain profit, obviously profit is revenue minus the cost. So we do have expression for both the revenue and the cost. The revenue is negative 0.4 Q squared plus 18,000 Q minus the cost, which is 20,000 plus 400 Q. With a little algebraic manipulation, we will be able to get the profit function as negative 0.4 Q squared plus 1400 Q minus 20,000. So from the previous page, we got an expression for profit which was negative 0.4 Q squared plus 1400 Q minus 20,000. Now if this is a quadratic function obviously, so using this we should be able to find the optimum level of production or what kind of quantity they had to supply to maximize profit and so on. Now let's look at another example, and this is a little bit different than previous one, so let me call this as example 2. In this example, we talk about book sales. So let's talk about a vendor or retailer buying books at $3 per copy. So this is the cost per unit. And they also have a fixed cost of $400 per month. Now let's talk about when they sell this, according to their experience, they notice if they sell these books at $15 a copy, they were able to sell 200 copies of the book. Now if they reduce the price to $14 per copy, they were able to sell 220 copies. In other words, for a dollar decrease, they were able to sell 20 copies more. Now using this information, can we obtain the profit function for this business? Going through finding cost, revenue, and the profit. Now let's talk first of all, talk about two ordered pairs here. As we said, Q is 200 and 220 are quantity, 15 and 14 are price. So if you make two ordered pairs, price and quantity, so $15 price, 200 units, and $14, I'm sorry, our x coordinate is Q, the y coordinate is price, remember. So if it is 200 units, that price is $15. If they were able to sell 220 units, the price is $14. So the slope here will be 14 minus 15 over 220 minus 200, which is negative 1 over 20. Now if I use the point slope form this time and use one of these points, let me say I use the 15 and the 200, I will have the price minus 15 equals negative 1 over 20, Q minus 200. So that will become price minus 15, 1 over 20 Q plus 10. So price is equal to negative 1 over 20 Q plus 25. So this is our demand or supply function connecting price and quantity. Now let's talk about the cost here. Let me call that is C, equals $3 a copy, so 3 times Q plus the fixed cost, which is $400. So that's our cost function. Revenue function, let me call that as R, price times quantity, and we do know price is negative 1 over 20 Q plus 25 times quantity is q. So we'll have negative 1 over 20 q squared plus 25 cube. So the profit, we call that as P, revenue minus the cost. So 1 over 20 q squared plus 25q minus the cost function, which is 3q plus 400. So it will work out to be negative 1 over 20 q squared plus 22q minus 400. So these two examples possibly be enough for us to think about how to create revenue, cost, or the profit of a business based on supply and demand. And like I said before, whenever we are trying to generate demand and supply functions, we use mathematical models and regression analysis. That's a little bit beyond, outside the scope of our discussion. But if you know statistical procedures, you should be able to get either quadratic or exponential or any other form of mathematical models, whatever that fits the data.